All right, so how are you all doing? Good? All right, so my style is fairly interactive, and so if you want to raise your hand and have a question, I would say go at it. The other thing is I want to thank you all for such a warm welcome. I love the new style here with the microphone setup and all. It's kind of fun. And what I understand is that we have not seen each other for a while. And one of the messages I want to deliver to you is that in a while, in DLP technology, a lot of things have changed. So this is one thing that we want to talk about. So just to give you an idea, DLP technology, millions of mirrors. And so you will notice that DLP is a leader in the MEMS category, from projection, cinema, and now with other alternative technologies like 3D printing, spectroscopy, and other such applications. Our key proposition is we enable flexible light management, and then I guess from an engineering point of view, it's very important. It's not just about creating great, beautiful images, but also able to do all kinds of things with speed and with light. So all you may know DLP from digital cinema or from your everyday projector. And so something like this may be very much where a large display, 8 million mirrors is possible. And so you go from here, and we've been able to go from here to something like this. And so from this type of display to this type of display. All right, so as I mentioned earlier, we digital switch, so 1 and 0s to steer light, either in or out. And then we are agnostic from a light energy. So we actually support lamp, laser, or LEDs. So as mentioned, just to summarize, is a MEMS, microelectromechanical system. We can achieve all kinds of resolution we want. It's extremely fast, and we'll talk about that a little bit later. It has extremely high fill factor and is a proven display technology. I mean, we've been using this technology for over decades. All right, and finally, we do support a wide range of wavelengths from ultraviolet up to near infrared, and that allows us to go in all different kinds of applications that require visible light, but also require near infrared and ultraviolet light. All right, so here in brief, you're going to see our differentiation, and I'll go with some examples that hopefully you'll enjoy. The first one is speed, and this is really one of the largest differentiations that we have. And speed is important in many different applications. And one application is 3D. So 3D, being able to display 3D in a movie is important. For gaming, fast speed is important. So we could easily support 240 hertz. So for gaming, it's important. And augmented reality, which is now a trend, is also very important. For augmented reality, speed is really important because you can not just support a single field augmented reality, but you can also support multifocal augmented reality. And this is only with our speed. All right. Second one is resolution. And so today we're able to support resolution from NHD, which is a 1/9 of HD, up to cinema quality, which is 4K. And so what we're able to do is we're able to pack a lot of pixels in a very small area. Yeah. And we've come up with architecture that actually can double the resolution with the same area. Same area. Yeah, double the resolution with the same area. Yeah. All right. Efficiency. So for mobile, ultra-mobile devices, efficiency is really important. And again, DLP in this case it has a great position because we are very light efficiency. And so when you require a lot of lumens per watt, DLP actually has a very good position in that space. Brightness. Brightness is a great story for DLP, and because we are a semiconductor device with a superstructure, we can support down to virtually 1 or 2 lumens, which is primarily used for virtual reality, up to 100,000 lumens for cinema. And we actually are able to support all that wide range in terms of brightness. Okay. All right. Form factor. So again, Form factor, we've been able to shrink those devices so small that now we're able to have Pico projectors or devices that you can actually have in your palm of your hand. And that was virtually impossible about 10 years ago. And last but not least, as I mentioned earlier, we are kind of wavelength agnostic, and we can support a wide range of wavelengths, and that's also a benefit that we can provide. Yeah. All right. So we do have a long history of innovation, and I won't go into details in all these timeline. It's a lot of timeline, but I do want to highlight a couple of details here. The first one is we at 2004 were able to get the highest volume MEMS supplier worldwide. So that this kind of gives us not just a position from projection, but also in the MEMS category, we were able to ship the highest volume in that time frame. So we went from cinema, then we started supporting classroom projectors, and then we started developing Pico projectors, very small devices. But we really started expanding our markets when we launched the first development kit where any developer could actually go ahead and start a development with DLP technology when that was only accessible to a few customers. Now in 2015, we finally brought a qualified automotive DMD device, which actually opened a new market, which was actually getting DLP chips into cars. Now, 2017 is not here, but you will see at the end of this presentation that there is some news to share with you today that, I'm hoping that you're going to be amazed. So there are 4 areas, as I mentioned before, that we have space: displays, and these go from Pico projectors up to cinema. We also have space in industrial, and you may not be aware of DLP technology in that area, but actually we do have position in that area where we actually have 3D printing, lithography, and other markets as well. And then sensing. So for sensing, we actually have a very small, unique architecture, with a high precision that allows for spectroscopy to be able to measure, for example, pharmaceuticals or other materials and be able to correlate if they are the same or not. And then finally, we have automotive, and we'll talk about, we're going to talk about each one individually. This is just a quick introduction. So first, we'll talk about display, and we actually have quite a bit of leadership. First is we have the largest number of solid-state projectors sold in the marketplace, and so that gives a great position. Solid-state is important because with lamps, lamps at the end of the day, they last 3,000, 4,000 hours, while LEDs and lasers can last virtually over 20,000 hours. And this one, I want to make you aware, there's a market called screenless TV, and also can be called mobile smart TV. And we've seen a tremendous growth in that market, from 25 to 50% year on year. And this market is mainly for millennials, where I can actually take this type of product and in my backpack and be able to display projection virtually anywhere. And I understand that in Korea, there's a lot of projectors sold like for camping and other applications. This segment is a segment that I assume that in Korea is actually just blossoming. And then speed, we talked about that, and I'll keep drilling on the speed because this is definitely one of our biggest differentiations. And it enables to do high frame rates. So for example, again, we talked about 240 hertz in a gaming environment. That's something that is virtually possible with our technology. Augmented reality, multifocal display. And now I'm going to go in a little bit more detail because you may be curious of what that is. So today for augmented reality, what happens is that your image, you're able to see an image right there in front of you when you wear glasses and you have a projection unit. And today, it's really only just one focal point. But with our technology, you'll see later that we can do many, many more very fast speed and be able to have multiple focal points that result in beautiful, real 3D objects on your face. Not stereoscopic, we're talking about real objects, 3-dimensional optics that we can actually do on your face. All right, and of course, number one, resolution. So you probably saw earlier this year that DLP enabled the first sub $2,000 4K projector. And so this is the first time that the market has seen a 4K projection unit just for under $2,000. And then also in the Pico category, we have been able to get up to 1080p, which is pretty unique as well in the industry. And then in brightness, we talked about it a little bit earlier, but yes, we are number one in brightness because we're able to get up to extremely high brightness in the market today. So for example, if you've been going to like a concert where you see like a big stage and you see digital objects projected on the screen or on the back, that's probably DLP technology. And also if you've seen these events at night where they're projecting into buildings and then everything is kind of dynamic and you see the buildings changing, all this, that's probably also DLP technology. Yeah. All right. So the key here for display is that we are not the number one leader for projection technology worldwide per PMA. And we've been able to enable from cinema down to Pico projection. Right. And so, you know, technology that was spawned from cinema is now available to go into extremely small applications like near-eye displays, augmented reality, into Pico projectors and mobile smart TVs, and then up to stage lighting, and then finally cinema. But all this technology has been spawned from cinema technology, where it is extremely difficult in terms of light, in terms of color, in terms of all these characteristics where cinematographers are very demanding about all that, and we were actually able to spawn all that technology from cinema technology itself. Yeah. And we're not just technology, display technology, but it's one technology that we're award-winning technology. Just last year, I believe, and you'll see on the timeline, we won, or Larry Hornbeck won a technical Oscar. That's actually for inventing the DLP chip as used for digital cinema. And we are the only ones that have been able to achieve that in the industry. So if you do not know much about the block diagram of the DLP chip, I just wanted to go very briefly and go over it so that you feel comfortable with it. So every time we meet, you now know the block diagram of the chip itself, of the system itself.
그래서 그 다음번에 또 말씀드릴 때 또 기억하실 수 있도록 이 블록 다이어그램에 대해서 간략히 설명드리고 넘어가겠습니다.
So at a top high level, the system, the projection system, the application is going to be comprised of electronics and an optical engine. And the benefit of this is we've been able to work with many optical engine vendors. So for the system integrator, the developer, who must be your target audience right now, they don't have to worry about the complexity of developing optics. Optics are already there, and there are actually companies local here in Korea can support optics. What this means for the developer is that they can just use something as simple as a 24-bit RGB parallel video device interface and then be able to focus on the electronics. All right, so the DLP chipset is comprised of three components. The first one is the DMD, of course, the digital micromirror device. The second one is what we call the display controller, responsible for controlling the display with the DMD and also responsible to make all the features of the DMD itself. And then the third one is going to be the power management device, which is responsible for providing power to the LEDs, the DMD, and the entire system. Okay. So again, not just for display, but also for sensing, our speed and flexibility, and also our ability to be able to use different coatings to support different light sources has also enabled the market for multiple things that we'll talk about you just in a second. So first, we have near infrared spectrometer, and we talked earlier. So this is a device that can be used for a system to be able to measure the color signature of a material. And one of the benefits that we provide is the so compact, but specifically is the low noise that is actually able to acquire, that actually is able to deliver. So we actually have a very large signal to noise ratio of over 5,000 to 1. And this actually provides precision. So for example, this can be used in agriculture to determine if the soil is good or the soil is bad. This can be used in pharmaceuticals to determine if the pills are good or if they're bad pills. And so can be used in many, many different applications. It can be even used for health, where you could maybe look at a lettuce and see if the lettuce is a good lettuce or a bad lettuce. So here's the headline. Headline is going to be, spectrometers that were only available in the lab are now available in the field because we make it much more portable, smaller, with the same precision that a lab equipment that is extremely expensive. Now, for example, our EVM costs $999, the EVM itself. So you know that for a fact that engineers can probably develop something, the same or even lower cost than that. So again, from lab equipment, which is expensive and big, to very portable spectrometers, this is what we're enabling today. Yeah. So another challenge out there is 3D scanning. And so today, 3D scanning is very slow and it takes time. Well, with our technology, we can actually use an extremely high resolution DMD and be able to scan in a big area at once instead of just going very slowly. And so this actually speeds up 3D scanning technology and also makes it affordable as well, where we may be able to see 3D scanning with high precision and for consumers. So for example, one of the challenges now is size. And with this 3D scan, with this 3D scanner, you can actually have a very small, compact, and be able to scan your tooth in a very high resolution. So that's something that we can enable versus maybe larger scanning systems available in the market. And then also for industrial applications, we have applications supporting lithography. And so for lithography, we're printing. So now we're going from scanning to printing. And for printing, in this case for lithography, in the past, people were using masks. So they would have to have a proprietary mask for PCBs. And now the DLP chip is enabled to do flexible scans. And so no more masks are required, increasing the flexibility for customers. And also 3D printers as well, now going from being able to print very quickly versus other technologies, and going from industrial, why now, down to consumers. Yeah. All right. And then for head-up display for automotive. So today, you actually can see cars that are incorporating DLP technology in their dashboards for head-up display. So if you don't know what a head-up display is, it's just a virtual image that is projected in front of you as you drive. And so you don't have to move things around. You can actually drive and be able to see in front of you a virtual image that gives you directions or gives you the speed or whatever have you, but all this information is right there in front of you. So we have an automotive qualified chip, which, as you know, automotive is very difficult and has very high quality standards, and we have a chip that is qualified. Secondly, and I want to pause on this one a little bit, right now we're able to project an augmented reality, an augmented picture, so you just don't see the arrow. You see the arrow on the road. You virtually see that out on the road. And with our technology, we're able to not just have a 12-degree field of view, but we're actually able to expand that even much broader to a point where, why not, maybe the entire windshield could be completely augmented. All right, so the other ones is, of course, high color saturation, constant temperature performance, which is very important in automotive. And as you probably are aware, in an automotive environment, a display to be able to sustain that type of performance is difficult. And then finally, if you want to wear your sunglasses and look good and be able to see through, we're really the only technology that can offer that. So the head-up display, maybe other competitive technologies, to use their head-up display, you have to remove your cool sunglasses. But with DLP technology, you can keep them on all the time and still see perfectly through that display. All right, and the beauty of our technology is that everything is available on TI.com. And so you probably know this about TI, that we are very web-friendly. And in this case, we have everything available publicly on the web with all the resources that you need to be able to start your design. And also we have an extensive ecosystem partners, extremely extensive, and some of them are here in Korea. For example, Seconics, Axe, Digital Optics are all here local in Korea. And what this results for the developer is quick time to market. So again, it takes about 9 months to 12 months or even further to develop an optical engine, but all these companies have all different types of optical engines available in the market today that a developer can use and just use a very simple video parallel interface. All right, so now we talk about one more thing. We said that in 2017 we're announcing something completely new. You probably don't have that in your thing, and this is the surprise. So what we want to do is we want to show you a video very quickly. It takes about 3 minutes, and it gives you an overview of what we're announcing today. So what we're announcing today is the most affordable EVM for DLP technology at $99. So now the technology for DLP technology that has been maybe accessible for some markets are now available for all markets with an extremely aggressive and good price at $99 for the EVM. And I'll walk you through the video as it goes through.
비디오 시청하시면 설명드리겠습니다.
By the way, the size of the EVM is about as big as a business card. So if you have a business card, that's the size.
EVM 크기는 명함 정도 되고요.
You plug it in, and then you display that image right there. So for assessing display, you can just plug and play.
그리고 바로 플러그 앤 플레이가 가능해서 이렇게 바로 이미지를 사용할 수 있습니다.
And if you start want to develop, then you pair the EVM with a low-cost processor. In this case, we pair with the BeagleBone Black.
그리고 이 제품을 사용해서 개발을 한다고 하면은 그 저비용 프로세서하고 결합해가지고 개발할 수 있는데요. 지금 여기서는 BeagleBone 블랙을 사용하고 있습니다.
And now you'll experience the favorite part of the video, the one I like the most.
제가 제일 좋아하는 부분이 상영될 건데요.
You'll notice that we can support on-demand displays and freeform displays just as follows. So right now you see a little video of a fishbowl.
네, 이게 언디멘트 디스플레이인데요. 지금 어항이 보이는 것 같죠?
And everything disappears, and it's virtually as if there was nothing in the back.
네, 지금 보시는 것처럼 뒤에 아무것도 없는 것처럼 보입니다.
So it's comprised by 3 components, the DLP 2000, DLP A1000, and DLP C2607.
네, 그래서 이 제품은 DLP 2000, DLP 1000 등 3가지 부분으로 나눌 수가 있습니다.
And these are applications in the future that we believe are possible.
네, 지금부터는 이 제품이 적용될 수 있는 어플리케이션입니다.
And many more applications.
이거 말고도 더 많죠.
And then if you want to find more, you can go to ti.com/DLP99. So what do you think? Do you think that's exciting? Yeah, we also believe that that's exciting too. Our closest EVM, so that for reference, is at $399. This by far is the most affordable EVM that we have done so far. So we heard you. I mean, we heard the developer, and developer, for Internet of Things, developer that is, using a low-cost processor, they wanted to have an affordable projection technology using DLP, and that's what we brought to the market. So, and you'll see it over there later, but there are 2 use cases for this EVM. The first use case does not require a low-cost processor. The first use case is just to see the image quality. You plug it in, 5-volt supply, plug in, and then you see these beautiful image, and then you can turn it off again. And the image is really designed to show colors, to show gray levels, and to also show icons that developers can use for the application. And then you can pair it with your favorite low-cost processor and using a 28, 16, 24-bit RGB parallel interface and I2C. And if you have your favorite processor, it's ready to go. Now, for BeagleBone Black, we have really developed drivers and all the software needed to just use it as a single display. And then the benefits, obviously, are going to be very similar to any DLP benefit. So by the way, the DMD is $19.99, and that's the lowest ever we've been able to do in terms of the DMD itself. The EVM is $99, and obviously these two are not to scale. I mean, so this one is much smaller, and this one is a business card size. So designed for low-cost processors, is power efficient, for portable applications, developer friendly, has a 16:9 aspect ratio, and then it really can do any sort of display, because you saw the fishbowl that became from square to round fishbowl. And there are a lot of different applications for it. And in fact, we believe that this EVM is targeting an entirely new, different target audience, including Internet of Things type of applications and smart home displays and control panels. And so in summary, if I have to give you a big, broad summary, DLP, we started as a cinema technology, digital technology, and we have really evolved into supporting many applications, many markets, and those including industrial, sensing, display, and automotive. And so now DLP technology is really all over the place, providing light management and steering light at a very fast speed. So we enabled smallest, brightest, great image quality, and automotive qualified as well. All these different type of positions. We're supporting groundbreaking light sensing, for example, spectroscopy, that's a groundbreaking, and then high-speed performance that allows to look at applications in an entirely different form. And last but not least, our technology is really extremely easy to use, and we are now able to provide a affordable $99 EVM DLP display solution, which is NHD, to the market, so that any developer worldwide can actually be able to buy this EVM, evaluate our technology, and start their next project. So if I had an action for a developer to do immediately, it would be go to TI.com. In fact, you can go to TI.com/DLP, look at everything that is available and possible, or they can go to TI.com/DLP99 to look specifically for this new $99 DLP EVM. And now we're going to transition to demonstrations. So you're going to get to see a wide array of demonstrations. You'll get to see a mobile smart TV. We talk about that category. And the brand is the Jimgo mobile smart TV. Then you're going to be able to see the splash screen that we talked about earlier. So you'll get an experience of that. You'll get to see a very small laser-based projector, tiny mobile smart TV. So it's a tiny mobile smart TV that incorporates laser. You'll be able to see a device that is able to virtually see images in front of your face as a virtual reality images. You'll see all of our EVMs, or a lot of them, and then you'll see in the back an optical engine from here, from Korea, from Digital Optics, that is ready, is an EVM, and that is ultra short throw, and you'll see that as well.